Hi everyone. Now we'll start with the topic differentiation. Good. What is the meaning of differentiation? The process of finding derivative. Process of finding derivative is said to be differentiation. So, what does exactly the derivative of a function defines? The derivative of a function defines how fast and in what capacity a function is changing. Okay? So, derivative of a function defines how fast and in what capacity a function is changing at any instant. I will explain you the definition of the differentiation. Take f of x. Let f of x be a function, a real function, and take any point a in the domain of f of x. Then the derivative of f of x at the given point a is defined as limit h tends to 0 f of x plus h minus f of a plus h, f of a plus h minus f of a divided by h. The derivative of the given function f of x at the given point a exists provided this limit exists. So when can I say that limit exists or a function is differentiable at a point in its domain? We can say that limit of the function exists when its left hand limit is equal to the right hand limit. Means the left hand limit of the function exists and the right hand limit of the function exists and they are finite and equal. Then we can say the derivative of the given function at the given point exists. What I meant to say is the left hand limit, that is limit h tends to 0 minus f of x plus h f of a plus h minus f of a by h, and limit h tends to 0 and limit h tends to 0 plus f of x plus h f of a plus h minus f of a by h. If these two are finite and if they are equal, then I can say that the limit of the function exists. So if the limit of this function exists, then the derivative of this function exists at this particular point. So how to define the derivative of the given function at a particular point? The derivative of the function at a particular point is defined as limit h tends to 0 f of a plus h minus f of a by h. This is also called as a fundamental theorem or differential quotient. There is a different form, the differential coefficient. I'll just help you an example, then I'll speak about the different form for the differential coefficient. For example, I would like to find the derivative of the function f of x is equal to x. Then the derivative is given by limit h tends to 0 f of x plus h minus f of x divided by h. So if f of x is equal to x, f of x plus h would be x plus h. So the given function is equal to limit h tends to 0 x plus h minus x divided by x. The positive x and the negative x gets cancelled. So h by x is 1. H by h is 1. So limit h tends to 0. The derivative of f of x is 1. Okay. Now, how we define or denote the differentiation? The differentiation of f of x is denoted as f dash x, or it can also be denoted as d by dx of f of x. Very good. If I take for example y is equal to f of x, the derivative of the given function can be written as dy by dx, or simply I can write this as y dash. There are many ways to denote a differentiation of the given function. Mainly we use f dash x or d by dx of f of x. If we represent the given function as y is equal to f of x, then I can denote the differentiation as dy by dx or y dash. This fundamental theorem of the differential coefficient is the most important one. You should be very clear with this. So if this limit exists, then I can say the derivative of the given function exists at the particular point when the limit exists, when the left hand limit and the right hand limit of the given function are equal. I just solved an example and show you how to find the differentiation of the given function f of x is equal to x. It is using the differential coefficient. So how can we denote a differentiation? It can be denoted by f of x, that is f dash x or d by dx of f of x. If I have written the function in terms of y is equal to f of x, then I can say that dy by dx or y dash. Good. As I said, we do have an alternative form for finding the derivative of a function at a specified value. So it is denoted as, what is the other form to find the derivative of the given function? Limit x tends to a f of x minus f of a by x minus. This is another form of the differential coefficient, which is most important. So from just now what I have spoken, if a function is differentiable at a particular point a, then the function also should be continuous at that particular point a. If a function is continuous, if a function is differentiable, then it should be continuous. So from this what I can say is every differentiable function is continuous. So what can be the converse of the given statement? If a function is differentiable, it should be continuous. Very good. Okay. So if a function is differentiable, it should be continuous at that point, or every differentiable function is continuous. Converse of this is, if a function is continuous, then f need not to be differentiable. If a function is differentiable, then it is continuous. Converse is, if a function is continuous, then it need not to be differentiable. So can you think of an example? Yes, let me give you an example. For example, we take the function f of x is equal to mod x. Take an example, f of x is equal to mod x or mod x minus 1. So I would like to show you that x is equal to 1, what happens to this function. How does mod of x minus 1 looks like? It looks like, as mentioned, one second, I'll just draw you. This is the given function of mod of x minus 1. So the function is clearly the continuous. Very good. So I would like to know what happens to this function at x is equal to 1. As I said, we have a different form for finding the differential coefficient, that is limit x tends to 1 f of x minus f of 1 by x minus 1. So I will find the left hand limit and the right hand limit. If x tends to 1 minus, we know f of x is minus of x minus 1 if x is less than 1, and we know f of x is equal to x minus 1 if x is greater than 1. Okay, good. So if x tends to minus 1, f of x is minus of x minus 1 divided by f of 1 is 1 minus 1 mod divided by x minus 1. That's equal to minus of x minus 1 by x minus 1, that is equal to minus 1. So what is the left hand limit of this function at x tends from 1 minus? It is minus 1. If limit x tends to 1 plus, it is f of x is x minus 1. F of 1 would be mod of 1 minus 1, that is 0 divided by x minus 1. So this is same as x minus 1 divided by x minus 1. So x minus 1 by x minus 1 is 0. So x minus 1 by x minus 1 is 1. Limit x tends to 1 minus is minus 1. Limit x tends to plus 1 is plus 1. So the left hand limit is not equal to right hand limit. So the limit does not exist. So hence the differentiation of this function does not exist at the particular point 1. So what I meant from this is, if a function is continuous, then I can't say that it is differentiable. But if the function is differentiable, definitely we can show that the function is continuous. Even I can show proof for this, but as of now it's not required, so I'm just going ahead. So we'll just recap what we have learned. We have learned the process of finding a derivative of the function is differentiation. Good. Then the most important thing is differential coefficient. We do have two forms for differential coefficient. If I would like to find the differential coefficient of f of x at a, it is given as limit h tends to 0 f of a plus h minus f of a by h. We do have an alternate form, limit x tends to f of x minus f of a by x minus a. And differential function is continuous function. Continuous function need not to be differential function. I have just explained with that with an example. Hope you are clear with this point, till this point. Make sure that you are clear with basics. Once you are clear with basics, calculus is very easy. Not only calculus, any part would be very easy. We shall go step by step and solve each and every step. So who thinks maths is very difficult, calculus is very difficult, they can go through this video and that definitely they will get confidence to solve any differentiation problem. Okay. Now I am going to enter into the problematic part. Like limit, many students, you could not, it is not possible. What I meant to say is differentiation is not difficult as limits, because here you have definite rules, definite formulas. Once you get hold of those, the differentiation becomes very easy. So we'll start with the formula part which is required for us. Suppose assume that you have two functions f of x and g of x. I have two functions, one is f of x and the second function I have is g of x. If I would like to find derivative of f of x plus g of x, derivative of f of x plus g of x, or derivative of f of x minus g of x would be same as derivative of f of x plus g of minus derivative of g of x. Similarly, for derivative of f of x minus g of x would be same as derivative of f of x minus derivative of g of x. Then we do have some derivatives which I suggest you to memorize and which are most important. So what are the derivatives to memorize? First and the most important thing is the power rule. What is power rule is? Assume I have a function y which is x power n. Then derivative of y is given by n into x power n minus 1. So the first rule is, which we are going to learn the formulas and which is most important to memorize. First and the most important thing we are learning is power. What is power rule is y is equal to x power n. So the derivative of y with respect to x is given as n into x power n minus 1. So for example, take y is equal to x square. What is the derivative of y with respect to x? Derivative of y with respect to x is given as 2 into our formula n into x power n minus 1, that is 2x. Take for example y as 6x power 5. So dy by dx is given as 6 into 5 into x power 5 minus 1, that is 30 times x power 4. Excellent. Next example, take y is equal to 3 pi x cube. So dy by dx is, I can write as 3 by x cube as 3 into x power minus 3, that is 3 into minus 3 into x power minus 3 minus 1, that is equal to minus 9 into x power minus 4, that is same as minus 9 divided by x power 4. Okay, so I'm just teaching you different possibilities. Suppose if I have y is equal to 5, can you guess what can be the derivative of this? You might wonder, there is no x here, then why he has given this? So this is called as, what is this called as? Y is equal to 5. Y is equal to 5 is a function, is a line which is parallel to x-axis. It is a constant function. So let us see what is the derivative of y is equal to 5, or what is the derivative of a constant function. How does a constant function change at different instance? So I can write 5 as 5 into x power 0, because anything power 0, if x is non-integer, is x is non-zero integer, is non-zero number is 1. So I can write 1 as x power 0. So derivative of y with respect to x is 5 into 0 into x power 0 minus 1. So that is same as 0 by x. 0 by anything is 0. So what I meant to say, this is derivative of constant polynomial function is always 0. Derivative of constant function is 0. Good. Now take a different example. Let y is equal to 7x plus 5. Can you guess what this function is? A linear function. So what is the derivative of the linear function? It is indirectly, it is in the form of slope intercept form, right? So if I find derivative of this function, it would be 7. So derivative of any linear function would be slope of that function. Go. I hope you are clear with power rule. Power rule is, if you have any function x power n, the derivative of the function is given as n into x power n minus 1. The power rule is so simple. Good. So we do have many more functions to memorize. Next set of functions would be trigonometric functions. Okay. What are the different trigonometric functions which you have learned in earlier classes? Please recall them everything. I can derive the differentiation of each and every function, which can be taught later. So I suggest to remember the derivatives of these 6 trigonometric functions. So since you have learned in earlier classes, you know these 6 trigonometric functions: sin x, cos x, tan x, cot x, secant x and cosecant x. What is the derivative of sin x? It is cos x. What is the derivative of tan x? It is secant square x. What is the derivative of secant x? Secant x into tan x. What is the derivative of cos x? Minus sin x. What is the derivative of cot x? Minus cosecant square x. What is the derivative of cosecant x? Minus cosecant x into cot x. Excellent. Can you observe? Can you observe something? I'm just going to give you 1 minute before I'm going to give you the answer. If you have found out the answer, very good. All the derivatives of the trigonometric functions which has cos, like cosine, cotangent, cosecant, are negative. So if you can just remember this, I am sure you will not have any difficulties in memorizing this. No one can confuse us. So derivative of sin x, cos x, tangent of x, tan x, cot x, secant x and cosecant x. Then we do have logarithmic functions. Logarithmic derivatives. So if we have a function ln of x, what is ln of x? Log to base e is called as, it is also called as natural logarithm. Ln of x means log to the base e of x is. So if I have ln of x, then derivative of ln of x is given as 1 by x. Suppose you have a function log x base 10. If you would like to find derivative of this function, it would be 1 by x into ln of 10, because ln of x base 10 can be written as ln of x base e on ln of 10 base e. So ln of 10 base e or log base e is ln of 10. Since derivative of ln of x is 1 by x, 1 by x ln of 10. Good. So if you would like to solve another example, so make sure that you remember these formulas. I'll just recap what you have learned so far. You have learned that what is differential coefficient, and then we have learned the derivatives of, which we need to memorize. First is power rule, then is trigonometric functions, then we are learning logarithmic derivatives. Then the fourth thing is exponential derivatives. Can you guess what are the different exponential functions we have? Exponential. What are the different exponential functions we have? E power x, and we do also have e power x. What is the derivative of e power x? Derivative of e power x is e power x itself, and derivative of a power x is a power x into ln of e. The strange thing about exponential function is, what is e? 1 plus 1 by 1 factorial plus 1 by 2 factorial plus so on is e. It's approximate value lies between 2 and 3. So if you do derivative of e power x, you still get e power x. Okay. And derivative of a power x is a power x into ln of e. So with the concepts we have learned so far, I'll just give you 1-2 questions which you can try on your own. But you make sure that you are clear with all this, what I have said so far, so it makes our life happy, easy to solve any question on differentiation. So take an example. If y is equal to tan x plus 2 times ln of x plus 5 power x, then what can be the derivative of this function? Derivative of tan x is secant square x. 2 into derivative of ln x is 1 by x, and derivative of a power x is a power x ln of a. Here it is ln of 5, that is y dash. How simple, right? I said you first you need to apply the algebra of derivatives, that is derivative of f of x plus g of x. Or you can have not only 2 functions, even if you have some 20 functions, or here I have 3 functions. So f of x plus g of x plus h of x is same as derivative of f of x. So if f of x is tan x, derivative of f of x is secant square x plus 2 times derivative of ln of x is 1 by x, which is g of x, and h of x is 5 power x. We know that a power x, the derivative of a power x would be a power x ln of 5. Now we are left with other set of important functions, which are inverse trigonometric functions. You just go through all this material and then you practice, then calculus would be so easy for us. Just make sure that you learn in a proper way and an easier way. Definitely calculus is to be the most easiest topic. Okay, we do have again 6 inverse trigonometric functions. Derivative of sine inverse of x. We have derivative of tan inverse of x. also have derivative of secant inverse of x. We also have derivative of cos inverse of x. We have derivative of cot inverse of x. We also have derivative of cosecant inverse of x. If you want, I'll prove it to you. Or what would be the derivative of each and everything. Let me write the result. I can take 1-2 functions and I can prove the result. Derivative of sin inverse of x is 1 by root of 1 minus x square. Derivative of cos inverse of x is minus 1 by root of 1 minus x square. Derivative of tan inverse of x is 1 by 1 plus x square. The derivative of cot inverse of x is minus 1 by 1 plus x square. Derivative of secant inverse of x is 1 by mod x into root of x square minus 1 minus of 1 by mod x into root of x square. So what similarity you can see here? I hope you got it by now. If you are clear with what I have thought for trigonometric functions. So derivative of all cotangent, cosine, cos inverse, cot inverse and cosecant inverse is negative. Derivative of sin inverse of x is 1 by root of 1 minus x square. So many students will ask me, sir, you just let me teach me how to prove for one. So I'll help you how to find derivative of any function. Take any function. Let me take, for example, let y is equal to tan inverse of x. I'm going to take function y which is tan inverse of x. Apply tan on both sides. So tan y is tan of tan inverse of x, which is x. So now differentiating it on both sides, tan y derivative is secant square y and y derivative is dy by dx and x derivative is 1. Therefore y dash is 1 by secant square y. For secant square y we can write it as 1 by tan square y. That is 1 by 1 plus tan y is x square. That's the reason why tan inverse of x derivative is 1 by 1 plus x square. So in the same way you can find derivatives of all other trigonometric functions. So with all the concepts which you have learned so far, we'll try to solve few problems. So what you have learned? You have learned what is differential coefficient, alternative form for differential coefficient, what happens to when the function is continuous. We also have learned power of trigonometric function. So then we have learned the derivatives which are required to memorize. The first one is the power rule. If y is equal to x power n, and the derivative of the given function is given as n into x power n minus 1. Then you have seen what are the derivatives of different trigonometric functions like sine, cos, tan, cotangent, secant and cosecant functions. And we have seen logarithmic functions, exponential functions, and we have seen the derivatives of inverse trigonometric functions. So these are most important, and I suggest each and every one of you should memorize them. It helps you a lot. So with these basics we will solve some 1-2 examples, then I'll go to the other concept. For example, if you want to find the derivative of x plus sine inverse of x. So from algebra of this we know that it is same as derivative of x plus derivative of sine inverse of x. Derivative of x is 1 and derivative of sine inverse of x is 1 by root of 1 minus x squared. So similarly, second example, find derivative of 5 power x plus 2 cot x minus log x based. So 1 by 2 into 5 power x sorry so what is the derivative of 5? It is same as derivative of 5 power x plus derivative of 2 cot x minus derivative of log x based. Derivative of 5 power x is 5 power x log pi ln of pi log pi base e plus what is the derivative of cos 2 into derivative of cos x is minus cosecant square x minus derivative of log 2x is 1 by 2 power x into 2 power x log 2. Last example, find the derivative of sine inverse of x plus cos inverse of x. That is same as derivative of sine inverse of x plus derivative of cos inverse of x, so which is 1 minus 1 by root of 1 minus x square. Let's put a 0. So practice them, memorize all the formulas which I have set. Then we'll see derivatives of composite functions, a chain rule, product rule, and we also have quotient rule. Then I'll take you what is the importance of variables, then implicit differentiation. Okay. I'll solve the example based on what all I have discussed. Then we go to parametric differentiation and etc. Hope you got what I said so far. Thanks for listening, watching this video.